everybody, yes. So everybody agrees that 2 is less than 5. Our goal for today is to learn how to solve inequalities. We've already in this unit solved equations. And in equation solving, the main idea is what you do to one side of the equation, you do to the other side of the equation. So when we had an equation like 2x plus 3 equals 7, first you would say, I'm going to subtract 3 on both sides, and then you would get 2x equals 4, because those were like terms, and then you could divide both sides by 2, and you get x equals to 2. So now we're going to do a little experiment to see if you're allowed to do that with inequalities. Question? Oh, okay.
Oh, yeah, that makes sense.
For inequalities, we do. We started it yesterday and it ends today. So question is, we're going to check if we can add, subtract, multiply, and divide, and to see if things still work out. Okay? For example, if you add 3 to both sides, is it true that 5 is still less than 8? So it seems we can add to both sides of an inequality. If you multiply both sides, let's say we times this side by 2 and this side by 2, is it still okay? All right? Are we thinking that it's always going to be okay? Yeah, like if I subtract on both sides?
Yeah.
Okay.
You're
Or,
subtracting the same number, and then it should be fine.
okay, well, so let's say subtract 3, subtract 3. Is it still true that 7 is less than 13? Okay, good. What happens if we, what haven't we done yet?
Divide, but that's not easy to divide.
Well, why don't we times it? Here, let's go back to this one. And then we do, let's check if we can divide. Can you divide by 2?
Yeah.
Okay. And we would get 5 is less than 8. Is that still true? Okay. How about if I subtract bigger numbers? Let's say if I subtract 10. Is it still true? Because, oh, no, I wanted to do not that big. I'm going to subtract 7. That'll be fun. What happens if I subtract 7 on both sides? Negative 2 and 1. Is it still less than?
Yeah. Yes, you do.
Okay.
But if they both go into negative numbers, that's when it.
Well, but there's one.
It still is less.
There's one thing that you can do, though, that makes it not true. Well, there's actually technically 2 things, but they're basically the same. Watch this. If I multiply this side by negative 5, and I multiply this side by negative 5, this side will be 10, this side will be negative 5, and now my sign doesn't work. So if you turn to your notes to solving inequalities, the method basically is solve like equations. So what you do to one side, you do to the other. And we combine like terms just like that. But there is one important new rule. And the one important new rule of solving inequalities is if you multiply or divide by a negative number, and only a negative number, then you have to flip the inequality. And this is what we saw. Okay, I'll let you finish writing this down, and then I'll show you some examples of that. This is today. But the notes we got yesterday. Yeah. And then the first part of the notes, you'll have to get from the YouTube channel then. Okay, check it out. Would you agree? You were not done? Almost? Okay, here, finish it up. So you solve like equations with one new special rule for inequalities. If you multiply or divide, where are your notes? If you multiply or divide by a negative number, then you have to flip the inequality. And check it out. Everybody agrees that negative 7 is less than 63. No? Okay, everybody except for Jackson agrees that negative 7 is less than 63. However, if I were to divide both sides by a negative number, what is negative 7 divided by negative 7? 1. What's 63 divided by negative 7? Negative 9. And now, 1 is bigger than negative 9. Notice the sign has to flip. When you divide by a negative, the sign has to flip. It's the only thing that makes sense. And if you forget the rule, okay? Because this is very typical of math students. If you just try to memorize a rule, you will forget it, and then you'll have no idea what you're doing on quizzes and tests, and your mark will go down. If you're like, ooh, what happens if I add a negative number? Should I flip the sign? Right? 8 is less than 10. I'm going to add a negative 3 and add a negative 3. This will be 5. This will be 7. Does the sign flip? No. But if I multiply, 2 is less than 3. If I multiply by a negative number, which one's bigger, negative 8 or negative 12? Negative. Yeah, I know, but think about your number line. Here's 0. Here's negative 8. Here's negative 12. That's bigger. It's further to the right. And the sign flips. So here we go. The rule, the new rule, doesn't always come into effect when solving equations. Oh, did I do it again? Just going to double check. Okay, I think I gave you just enough space to solve these if you write small. So, step number 1, we're solving this like equations. Do you see that the 14 and the 34 are like terms? And so I can move the 14 to this side by subtracting 14 on both sides, and then I would get 2x. I didn't give myself enough space. 2x is greater than or equal to negative 2r, thank you, is greater than or equal to 20. I'm going to erase the second question just so I have enough space.
How do you solve from here?
Well, what's the opposite of multiplying by negative 2? Divide by negative 2. And here, you treat it like an equation.
So like the inequality sign is an equal sign, right?
It's like an equal sign, except we have this one important new rule, and that new rule comes into effect right now when you divide it by negative 2. So I'm going to put a red star at that spot because our new rule came into place. We had to flip. R is less than or equal to negative 10. So you solve it like an equal sign. You keep your inequality sign the same unless you multiply or divide by negative.
So you don't really figure out the actual answer of it. It's just like
It's a bunch of answers, right? Like sometimes they'll say, can you put your answer on a number line? And then we would have to do a full circle, remember, for the equal sign, and draw the arrow going backwards because it's less than or equal to negative 10. Okay. Everybody got the first example down? Because I'm going to erase it. We're good? Let me just double check. You've got the first one down. You got the first one written down. Okay, you got the flip part. You're working ahead. Okay, I'll wait a little bit. There's a few people that haven't got these notes down, so I'm going to wait for them. All right, so there's the second one. Since we divided by 2, we do not have to flip the sign. All right, here we go. The third one. Yeah. Right now, there's no like terms in number 3. M is being divided by 5. If we want to get M by itself, opposite of dividing by 5 is multiplying by 5. So in this one, the sign, again, it wouldn't change because we multiplied by a positive number.
really I figured out how to do that dividing one. No, never mind.
All right, example number 4.
Yeah, that's exactly.
So in example number 4, we do have some like terms. Notice we have a -2 and a 26. We're going to move them to the same side. I'm going to move them to this side by adding 2 and adding 2 so that my variables are on one side, 7x, my numbers on the other side. And since I added, we never change the inequality sign. And now to get x by itself, the opposite of multiplying by 7 would be to divide by 7. And so many, many, many solving inequality questions end up being identical to solving equation questions. Nothing happens to the sign. It stays exactly the same all the way through. It's only when we multiply or divide by a negative that we have this new rule come into place. Everybody's good on this one? I can erase it? I think this is the time that I gave myself not enough room. And are you guys, is it enough space, or it'd be nice if it was a little bit more?
A little squished, but it's okay.
Okay. So I'm going to make a note for myself next time to revamp these notes to make them better. Okay. Complicated, this question, because we have like terms, but this whole side is being divided by 6. So the First thing is we're going to multiply both sides by 6. We don't have to change the sign. It's going to be negative 2d plus 4, because these 6's will simplify. Greater than or equal to 1 times 6 is 6. Then these are like terms, the 4 and the 6. So I'm going to subtract 4 on both sides. And I'll get negative 2d. No, because this is all divided by that 6. So when you multiply, it cancels out. That whole side is divided by 6.
Oh, yeah.
So
I did that.
So subtracting 4 on both sides, I get negative 2d is greater than or equal to 2. And here, we now have to divide by negative 2. And so our special rule comes into effect. We have to flip the sign, put a little star, and write flip, highlight that one, because we divided by a negative number. Good on this one? Okay. 2 more to go on this page. Excuse me. Okay. Question number 6 has multiple like terms. Do you notice that you have a 4k and a 2k? So I would probably decide to move my k's to the right side so that they stay positive. So I'm going to subtract 2k and subtract 2k. And then I have a 16 and a 4. I'm going to move my 16 to this side, so I'm going to add 16 and add 16. Looking at what I have left then, negative 4 plus 16, I will have 12 on this side. And 4k minus 2k is 2k. I now have to divide by 2, and I will get 6 is greater than or equal to k, which, if you like to write it with the variable on the other side, then you have to say 6k is less than or equal to 6. And just for fun, look at what would happen because there are some people that always like their variable on the left side. So if you had decided right at the beginning that you wanted to move your 4k over, and that would mean moving your 4 to this side by adding 4 and adding 4, you would get negative 2k greater than or equal to negative 12. And dividing by 2, or dividing by negative 2, would get k by itself. But since you're dividing by a negative, what do you need to do to the sign? Flip it. But notice that it ends up with the same answer. So depending on which way you go about it, you get the same answer. Do you want to, here, I can give you some time to write down number 6 here before I erase it. For number 7, we have distribution. So step number 1, we'll draw our arrows. We can distribute the number. And so in solving equations, if you have math that you can do on a side, do it. So we can distribute. And now we have like terms. Generally, I would say move the x's to the side to keep things positive. So subtract 2x on both sides. These are like terms. That would mean I'd move my numbers to the other side. Means I have to add 12 and add 12. 2 plus 12 gives me 14. 4x minus 2x gives me 2x. Opposite of multiplying by 2 is dividing by 2. And you get that 7 is greater than x, which you can read the other way. X is less than 7. All right, turn to your last page of notes for this unit. Get to some word problems. Does Sarah have nice parents?
Yeah.
That's pretty good wage. Parents are paying her more than minimum wage. Did you know that Manitoba has the lowest minimum wage in all of Canada?
It's bad.
Okay. Huh. I got a spelling mistake in here. There we go. This is an inequality. We can So first of all, we need to define what our variable is going to be.
Yeah, what if Sarah's a man?
Well, then I had to change 3 pronouns, so I just changed the 1. Could be. So Sarah earns $14.50 an hour working for her parents. And her goal is to earn at least $600.
Oh my goodness, that's a lot.
Okay? Because it says at least, it makes an inequality rather than an equation. If she wanted to make exactly $600, that would be an equation with an equal sign. But since it is at least, we have to write an inequality. Now, if x is the number of hours she works, how much money does she make? So I'm asking you, how much money does she make if she works 5 hours? What would you do?
5 times 14.
5 times 14. If she worked 10 hours, you would do 10 times 14.5. If she worked X hours, you don't know how much she worked, she would make $14.50 times X. Does that make sense? Now, it's not going to be equals because she wants to make at least 600.
Over or greater is less than
Which,
less or the same as 600.
does she want to make less than or the same as 600?
More than.
She wants to make at least, so that would be greater than or equal to 600. How many hours will she need to work? Now we can solve for x. What's the opposite of multiplying by 14.5? Dividing by 14.5. This would be a calculator question.
It's a weird number. It's like
41.38. Yes, it is a weird number. So, would 41 hours be enough? So because it's a word problem, we need a statement. We could write it like this. Oh yeah, X, thank you for noticing that. X is bigger than or equal, thank you. She would need to work more than 41 hours.
Smart word, your hair really shines for the
The
see all the loose. So
Oh,
here,
you just went ahead and did, yeah.
so I'm assuming they're getting 3 marks because 1 for the answer and just
One for
the
showing the
work.
work, yeah.
Would that be considered just showing their work?
That would be fine, yeah.
So it'd be 3.
Yeah.
And I got 140, but it's approximate.
Yes,
so,
that's right, yeah.
And then 2 marks, 1 for constructing the graph,
Yeah.
and
Construct a graph and table and 1 mark for the table values.
right. And
They
that
did
would
a
be
couple,
cons-
yeah. Yep. Awesome. Do you want to wait until we're finished the notes and then that way you have all the notes done and then go at that time? Yeah. Okay. Okay. Second word problem. Chris builds dog houses. Each one sells for $115 and takes 4 hours to make. Pretty good wage, right? He's making over $25 an hour. I guess there'd probably be material costs. So you got to take that into consideration. Chris wants to make at least $1,000. How many dog houses will he have to sell? So, first of all, one dog house sells for 115. What are we going to let X equal? Number of dog houses sold. So 115 times X is how much money he wants. He wants to make at least $1,000. So I have 1,000 on this side. What inequality sign will I put in the middle? This has to be greater than or equal to 1,000 if he wants to make at least 1,000. How many dog houses will he have to sell? So we divide both sides by 115. We go to our calculator. 8.7. Thank you. Now, I don't know, but it's pretty hard to buy 0.7 of a doghouse. So what would you have to say? He would need to sell at least 9 dog houses. So notice, I'm going to underline this part because we have to use inequality language in our answers as well. He doesn't have to sell exactly 9 dog houses. He could sell 15. Now for part B, Chris wants to work no more than 50 hours. Okay? So now we're talking about hours. Each doghouse takes 4 hours. So does it make sense that every doghouse that he makes will be 4 times X? That'll be how long he'll have to work. And he wants that to be no more than 50 hours. Less than or equal to. So divide both sides by 4. X has to be less than or equal to. Right? So what are we going to say here? He would have to make, you could either say less than 13 or less than or equal to 12 dog houses.
No, wouldn't it be more? It'd be more or equal to, because it's 12.5.
But the answer is x is less than or equal to 12.5. He can't make a half a, well,
He could start the dog house and then
but if he's going to be stopping completely after 50 hours, then it's no use of making. So in some of these, it's open to interpretation when you write your answer, right? If some of you would believe he could still make half a doghouse and just be like, next time he gets back to it, he would start from there, I would accept that. And our last example, you're planning a sports banquet. The cost of dinner is $450 plus $24 per person. So you probably have to pay $450 to rent the space, and then each meal is $24. So if you're the only one going to this sports banquet, it's going to be a really expensive meal for you. Okay? Okay. Yeah. Sounds good. Yes, each person pays. So let x equal x equals the number of people that are going. So does it make sense that the total cost is going to be $450 plus each person that comes has to pay for a meal of $24, so 24x. And we have a budget of $2,000. What symbol has to go in between there? This is your total cost. It has to be less than or equal. So now we have to solve this equation. We notice that these are like terms, so we could subtract 450 on both sides. And now opposite of multiplying is dividing. 1550 divided by 24. I don't feel like it today. I know. 64.58. I could have. I know. So what is our statement? Right? The question is, how many people can attend?
But it could be 65 too.
No, 65 would be over your budget.
Yeah, true.
So again, I'm going to use language in here. This time I used up to. How's that for English language words? There can be up to 64 people who could attend. Sometimes people like to say, exactly like the sign, there can be 64 people or less. You could write that as well. Bottom of your page, there's homework out of your textbook to do. You just got your pretest. It has concept 1 on your pretest is equation solving. Concept 2 on your pretest is all the inequality stuff. The pretest, so we've got time. You can either do the homework at the bottom of this, or you can do your pretest.